is compound probability. So instead of just one event occurring, we are going to do multiple events. But in Algebra 1, we deal with two events. When you get to Algebra 2, there are more than just two events. So there are two types of compound probability. One is an independent events. That means two events occurs at the same time. Without affecting each other. So if I roll two die, one would not affect the other of what you roll, right? So that's considered to be an independent event. Or let's say you have Scrabble tiles and you got some letters there. I want to know what is the probability of picking a letter A, and then when I put it back, what is the probability of picking a letter B? That is still considered an independent event because it doesn't affect the second probability. Okay, so that's an independent event. Now the dependent would be then the opposite. It's where the first event affects the second event. So if I have that tile, let's say I have 15 letters, some are A, some are B, some are C's. What is the probability of picking a letter A? I don't put it back in. And then what is the probability of picking a letter B? The probability for B changes because I don't put the tile back and I have one less tile. So that would be a dependent event. So everybody understand the difference? Okay, and then you can tell by the words. And the way they state the probability also kind of tells you whether it's independent or dependent. Okay, so probability of two independent events is written like this: P, probability of A and B. Okay, so this is an independent. So you find the probability of A, and then you multiply by the probability of B, and that will be the probability of the two events happening. Okay? So you just multiply. And then probability of two dependent would be, they write it as A, that's your first event, then they use the word then, and then B happens because the A affects B. Okay, and this one you do the same thing, find the probability of A, and then multiply by the probability of B after event A has occurred. So you're still multiplying. Okay? So any questions with this? I'm going to give you a couple examples and then we'll be done. All right? So probability of independent and probability of dependent events. All right, so here's example number 1. I have 3 quarters and 5 dimes. in my pocket. You take out one coin and then put it back. Then take out another. So do you think this is a independent or dependent probability? Independent, because you're putting it back. The word put it back makes it independent. So whatever the probability, so I want to know what is the probability of taking out a dime and then after you put the dime back in, probability of taking out a quarter. That's what I'm looking for. What is the probability of taking out a dime first, putting it back, and then taking out a quarter? So, what is the probability of taking out a dime? 5 out of
8.
8, because there's total of 8 coins. And then, now I put the dime back in.
Heck yeah.
Now, what is the probability of taking out a quarter?
3 out of 8.
3 out of 8. So the total amount did not change because we put it back. So these are independent of each other. So you just multiply. So you just multiply straight across. You do not need a common denominator, okay? When you're multiplying fractions.
15 out of 64.
15 over 64. That is the probability of independent variable, independent events where dime is put back and then quarter is taken out. Okay, so any questions with this one?
No.
Okay.
She stayed the night so she gives you
All right, so here is example number 2.
Heck yeah.
We're going to use the same situation, same as above, but you do not put it back. Do not replace. Okay? So you still have 3 quarters, 5 dimes. You take one coin out, but do not put it back. You keep it out, and then, so do not replace the coin. So now I want to know what is because it's do not replace, this is dependent. And then when you replace or put it back, this is independent, okay? So in this case, I want to know what is the probability of taking out a dime and then a quarter. Okay? So, what is the probability of taking out a dime? 5 out of 8. First probability is still the same. Now, I don't put that dime back in.
3 out of 7.
So now, how many coins do I have?
3 over 7.
3 quarters out of a total of 7 coins now. 3 out of 7.
17, dude.
Okay?
15 over 56.
So you multiply straight across. So 15 out of 56 will be that probability.
Julia, will you please get on my
Okay.
level?
So what do you think so far?
Hashtag easy.
Easy? So dependent total amount changes, all right? Now what if I say, let's do the same thing again. This time I want to take out a dime, and then I want to take out a dime again. What is the probability of that happening?
Hold on, let me.
5 out of 8.
No, Julia.
Yes,
Yep,
it is.
5 out of 8.
Then
You keep that dime out.
4 out of 7. Oh, wait, no.
4, 1 less dime.
Over 7.
So 4, and then 1 less coin. So it is 4 out of 7.
Get on
Wait,
my level,
hold on.
Francis.
Let me think this through again. You take a dime.
Keep it out.
The dime, there were 5 dimes, right? So we take a dime.
Keep it out.
That's 4 dimes.
Out of how many coins now?
7.
There you go. Now when you could reduce, 4 goes into 8
20 out of
once,
56.
which makes it 5 out of 14.
We have to.
Okay? So you may reduce.
Can I get some homework?
I will
I'm kinda
reduce
sick of being too
if you
smart for this
can.
class.
Okay? So any questions with this? This is a compound probability.